So today I'm talking about the Alluxio. Formerly we were called Tachyon. We renamed it about a month ago. It's a memory speed virtual distributed storage. I'm Haoyuan. People also call me HY. I'm the CEO of this company called Alluxio as well. So just one slide about the company. It's founded by Alluxio open source project creators as well as the committers. So we got our Series A from Andreessen. We're committed to the open source Alluxio project, and that's our website. So about myself, I'm the co-creator of this project while I was at UC Berkeley AMP Lab doing my PhD there, and now I'm the CEO of this company. I'm also a founding committer of Alluxio project, founding committer of Apache Spark as well. Great, so here's the outline of the talk today. I'm going to introduce what is Alluxio and why we're doing Alluxio, this project. What's the trend we're seeing and why it's legit. And then we'll talk about several use cases to further state, like see how people are using Alluxio to show how people are following this trend in the industry. So first of all, Alluxio is an open source memory speed virtual distributed storage. So you see the four highlights there: open source, memory speed, virtual, and distributed. So what does that mean? The open source, well, one of the fastest growing open source projects. We have some numbers later on to show. And we have memory speed because we have a memory-centric architecture designed for the memory speed I/O. And we are virtual as well. We have a unified namespace which abstracts the persistent storage from a lower layer from the applications. And we have some slides to talk about later as well, and we're distributed. So we scale linearly with the number of machines, commodity hardware. So a little bit background of a project. We started this project back in the UC Berkeley AMP Lab from the summer of 2012. The same lab produced Apache Mesos as well as Apache Spark. And we open sourced it second year April, which was around 3 years ago on the Apache 2.0 license. And the latest release is version 1.0.1, which was actually March this year. And it's deployed at more than 100 companies nowadays. So we mentioned the project is growing fast. We have close to 250 contributors, to the developers contributing to this project. It's about 3 times growth over the last year. And we have over 50 organizations are contributing to this project as well. This is a partial list of these companies, like IBM, Intel, Huawei, all these companies. And we talk about this, it's a fast growing, but this is just a graph to show, compare with other popular open source projects as well. So this is a number from the Git history of different projects. This is the number of contributors to the project for the first 3 years. And you can see it's Alluxio compared with different projects, popular projects out there. Great, so what is Alluxio? It's a memory speed virtual distributed storage systems. And it sits between the application layer, like distributed application layer, like Spark, MapReduce, like HBase, like H2O. We have another talk later on about H2O. And different type of persistent storage down layer. Say for example, you may have cloud storage like Amazon S3, Microsoft storage, have Google storage like Google Cloud Storage, or you have other open source storage like Gluster, like HDFS, like Ceph, or you have private cloud storage like OpenStack Swift, or you have traditional storage like EMC, NetApp, IBM, Huawei. Those all different types of storage. And we insert Alluxio in the middle to bring the benefit to the whole ecosystem, which I'm going to explain in the later slides. So then the question is, why do we want to do this system called Alluxio? So we're going to talk about several trends here. One trend is the performance trend for the memory. So on one side, memory throughput still increases exponentially every year. On the other side, disk throughput increases slowly. So you have the result that memory locality is the key to achieve interactive response time. If you want to do fast responsive query, you have to leverage memory. And that's what we see with different use cases. And same with the memory hardware, DRAM hardware. So the cost of DRAM decrease exponentially as well. So every 18 months, the DRAM cost decrease about 50%. as we can see, a lot of companies start to embrace DRAM technology aggressively at different places, like Wall Street, like Google, Baidu, for internet giants, and now it's the rest of the world. We still embrace this DRAM technology. So this trend has been realized by many people. Say, for example, SimLab will produce Apache Spark. You have HANA in-memory database, and you have many other things as well. So that's the trend. But the thing is, even with different computation, in-memory computation engine being proposed by different vendors, the problem is still not solved. Why is that? We're still missing a solution for the storage layer. So that's the trend we're seeing, hardware trend we're seeing. But beyond the hardware trend, there is another very interesting thing about the industry. Let's take a look at the whole ecosystem. Why do we want to do this system from the ecosystem perspective? So let's look at the big data ecosystem. As I mentioned, there are basically mainly two layers if you highly abstract this. So for example, on one part, upper layer, that's a compute layer. You have Spark, you have MapReduce, you have Flink, you have HBase, Presto. On the other side, you have different type of storage systems. Like you have Amazon S3 Swift, OSS from Alibaba, you have HDFS, Gluster, and this list goes on and on. And you will see that there are many vendors, they are creating new frameworks as well, new storage as well, and for the different performance characteristic of the system itself. And some companies, they are building their own system as well to fulfill their particular use cases. And with this ecosystem, how do these two layers talk with each other? So what we can see, that's the way they talk with each other. So basically, for every single application, they want to talk to as many as possible different storage systems, like Amazon S3, like all these different systems, to plug into the ecosystem. And that's the way they build a connection. And different layers, different underlayer storage systems, they also want to talk to as many frameworks as possible to plug into different use cases or workloads. That's the way we see it. But there are some issues about this particular way, of this particular view. So first of all, it's very costly to integrate into this ecosystem. So for example, you have a new system and you want to plug into different storage, you need to build a lot of connectors. That's one thing. And the other thing is, typically with this type of ecosystem, when you have a new project, you want to do another cluster. And when you do this cluster, you basically, normally you do say, I want to create a new storage system with this cluster. In the meantime, you want to have another application on top of it. And so what your ops will do is that they will ETL a lot of data from other storage systems in your enterprise environment into the new system. So this ETL process is very costly. And because of the ETL, you are basically making a copy of the data you already have. And you have a very expensive data duplication issue. And because you have so many different data storage in your data center, you have data silo as well. And you have a nightmare data management issue. And beyond this, because you have to do this ETL for every application, new workloads you are creating, new data center you are creating. So you have a long cycle to do the ETL. Before you can do any meaningful analytics, you have to migrate the data. This process takes months sometimes. So that's the problems we're seeing. So with this problem, we propose Alluxio in the middle. So basically, the goal is that different frameworks, they only need to talk to Alluxio in the middle, and Alluxio will talk to different under-storage system in the lower layer. And you have a lot of benefits because of this. And of course, you will solve the issues we mentioned in the previous slides. And we have a memory-centric architecture, which provide a very fast performance. On the other side, we have a unified namespace, which allow you to query any data from any storage system. And in the Alluxio layer, we have different APIs to make the upper layer applications life much easier. So you can think of, say, nowadays, if you have another application, as long as you talk to Alluxio, you'll be able to talk to any storage from any data from any storage. And if you have another storage system, as long as you plug into Alluxio, you can make sure different applications talk to your storage as well to extract more value from the data stored in this particular new storage system. And you can see, so Alluxio here, we enable any application to access any data from any storage at memory speed. And we enable new workload across different storage systems. And you can choose to work with any framework of your choice, or even your own particular internal closed source workloads. And the other thing, another big benefit you get is that because of this, you can separate your storage cluster as well as your compute cluster, which enable you to scale your compute cluster as well as your storage cluster independently. Before this, say if you have a co-located cluster, what our customer usually see is that, say, you either will be CPU bounded. In that case, you need to scale or you buy more machines, and you are storage bounded, you buy more machines as well. But if you are CPU bounded, you waste storage resource. But if you are storage bounded, you are wasting CPU resources. So that's another benefit we see from this. So then, with Alluxio system, so we basically we can power up your workloads both in the cloud and as well as on-premise as well. So for example, you have Mario here, and you with Alluxio become a much bigger Mario. So great. And with this Alluxio system, I just want to mention several use cases, in which case you may think of, you can map your own use case into this new architecture as well. So one use case is Baidu. They're querying data 30 times faster with Alluxio. Basically, they run Spark and Spark SQL on top of Alluxio, and below Alluxio they run their internal Baidu file system. And for this particular production deployment, they use Alluxio to manage local memory as well as HDD. We have a tier storage inside Alluxio as well, and they manage more than 200 nodes in this deployment with more than 2 petabytes of memory managed space inside Alluxio. And this has been in production for more than a year. That's one use case. Another use case is Barclay. That's an article they wrote called Making Impossible Possible with Tachyon. Back then we were still called Tachyon. And they use Tachyon to accelerate Spark jobs from hours to seconds. And they run Spark on top of us in this particular use case. And they use Alluxio to only manage memory. They basically move the data from Teradata into Alluxio and query from there to get a much better performance and relieve Teradata from other workloads in their deployments. Okay, so another use case is QUNR. So that's a NASDAQ company. It's China's Expedia, and they use Alluxio. They run streaming workload on top of it, and they also use Alluxio to share the data efficiently between streaming processing and their batch processing, and use Hive in this particular use case. And below Alluxio, they use Alluxio to manage both HDFS and Ceph. And they use Alluxio to manage memory plus HDD, and they have a 200 nodes deployment. And they are running this system in production to do real-time metrics processing, and it's sub-second latency. And this is the oil company, and the theme is similar. Basically, you run Spark on top of Alluxio in the middle between Spark and the Gluster file system, and Alluxio manage memory only. You can analyze the data in the traditional storage. And there's another one, you run Impala on top of Alluxio on top of Amazon S3. They have a 15 times performance improvement in this case. And there's a biotech company. They run Spark and MapReduce on Alluxio on top of Gluster. And you can use Alluxio to manage memory plus SD. And there's a SAAS company. This is very interesting. They run Spark on top of Alluxio on top of S3. And because their cost analysis, they found that using Alluxio to manage SSD only will bring enough benefit to them. So in this particular case, they use Alluxio to manage SSD only. Okay, and this is a retail one. This is a Spark and MapReduce on top of Alluxio and HDFS, and you use Alluxio to manage memory. And this is very interesting. And this company is moving away from HDFS to another storage. And in the meantime, they use Alluxio to spin out like on-demand compute cluster to guarantee the efficient data movement. Yep. So that's pretty much it. from the talk. And from these slides, if you have more interest, you can go to our project company website. You can go to our GitHub or Meetup group in the Bay Area. That's all. Thank you.
Very cool. What's in the water at the AMP lab? We had Florin from Mesosphere. We had the CEO of Databricks. We had like plenty of people. All those projects that came out of AMP. What is it about that place that creates so many great companies?
Oh, I mean, I was lucky to join a great lab. I think the lab is very. On one side, it keeps people in the lab, they try hard to dive deeper into technology. On the other side, we have a close interaction with the industry, and we're trying to see what's a real problem from industry and try to derive like solutions or more general solutions for different problems from the industry. And we have a great environment. Professors in the lab, they give us opportunity to talk to all the people in the industry as well, to enable us to solve interesting problems. So I think that's at least in my case, I think that's the reason. Yeah. Okay, great.
Tell us about how you've been building this open source community, which is always the hard thing to do.
Yeah, so...
Other than the meetup?
Yeah, sure. So we have a very fast-growing open source community, but on one side, I think we are solving an interesting problem, and no one was trying to solve before. And we were trying to solve this problem like several years ahead. Like I co-started this project around 4 years ago, and the first open source release was around 3 years ago. At the beginning, no one paid attention, but it's just the way it is. Just very few people start to contribute. But as long as you are solving some interesting problem, and people start to add on. On the other side, I think I was lucky in the sense of this lab. They already create a lot of like trust from industry, and people inclined to believe in the project created by this lab. So when I started this project, it's already like 4 years later than other projects from the lab, like particularly like Mesos and Spark. They are very successful industry, and from that perspective, you know, like people like they just pay more attention. But on the other side, like we are very open as well. We are open to a lot of collaborations. It's a lot of hard work there as well. So I remember back in the days while I was in the lab. Every week, I probably spent like 2 days, full time, 2 days, to talk to the community, to talk to different companies in the community. That's also one of the reasons that I found that it's not scalable anymore. Has to start a company to push the vision further along to realize the vision. So that's I think all this added together, we are pretty proud of the progress we have made regarding about the community. Yeah.
Great. One last question from me, and then we'll pass it on to people here. So you're ready for a very New York question?
I'm sorry?
Are you ready for a very New York type question?
Oh, sure. Yeah, any question.
So how do you make money?
Oh, yeah, we don't talk about this. We're still in the stealth mode. We don't talk about this, you know, in public yet, but we will announce later on. But if you have, you know, if you're using it, in general, if anyone is using it, if they are seriously using it, they in general contact us, and we will try to work something out as well with the different companies in the industry. Yeah, but for now we don't talk about much. Sorry about that. Yeah, yeah.
Okay, terrific. All right. Do we have questions? Do we have a mic?
Hi, I have two questions. One is, I remember about a year ago on Databricks summits, on Spark summits, they were talking all about Tachyon, and now they kind of silently dropped that, you know, word or that kind of thing. Does it mean that they were collaborating with you guys and now they don't, and then you changed the name even? I mean, that's the first question. The second question, more substantial. Why do you think that injecting yourself in the middle of that kind of two lines of ecosystem components and providers of the data file system will be more beneficial for the companies rather than developing the ecosystem components connectors to really good file system, like, for example, MapRFS, which was not even mentioned here.
I see. Great, awesome. So for the first question, actually, the first question I understand is two questions. Why we are changing the name? The other one is what's the relationship with the Databricks? So I think from Databricks, I don't know, but from Databricks perspective, they have their own focus. But we do talk. I mean, Yang, who's the founding CEO of Databricks, he's my PhD co-advisor. I mean, we talk all the time, and we do have collaboration. So that's the first part of the question. And the other part of the question, why we're changing name, is totally orthogonal to all those reasons. So so the community is growing stronger and stronger, and to Tachyon is a very crowded trademark space. And there are company, we feel like it's safer to pick a name cleaner for the long vision of the community as well as for the company. So that's the reason why we're changing name. And for the second question you mentioned, so you mentioned for 2 layers, why we're building this thing in the middle, and some system we didn't mention on 2 layers as well. So we built this common layer, and coated just since you mentioned Databricks, Yang is very supportive to us, the founding CEO of Databricks. He recently stated that he believes that Alluxio to storage is IP to internet. So we believe that we can achieve a lot in our layer. And on one side, even though now we have a file system API, but with the file system API, you can build anything on top of it. And we have a alpha key value API on top of this file system API. And in the meantime, we encourage the community to build all different ways to access data for the upper layer. And just a key value API just a showcase. On the other side, you mentioned that there are other systems I didn't list in that picture. Of course, so hundreds of systems, like on the upper layer, or lower layer. So we couldn't list them all, but whoever, I believe there are people running MyPowerFS on top, Alluxio on top of MyPowerFS, but because of space limitation, we just couldn't list them all. We wish we could, yeah.
Okay, so let's do another very quick one. Does anybody have a quick question?
Real quick. Do you work within a GPU accelerated environment well?
Yeah, that's a great question. So for now, not I'm aware of. Yeah, but there are people asking that feature, just not too many. Yeah.
Great. Well, thank you very much. Appreciate
all right. Thank you, everyone.